All right, so we're going to be using systems, which is what we talked about yesterday. So you can either solve graphically, using elimination or substitution, and with a word problems, basically. Okay, so your practice test actually has almost exactly the kind of problems that you're going to see on the test, but with different numbers, if that makes any sense. So if you can do those types of problems, then you can be able to do it on the test. All right. So the first one, I'm going to read it to you. We're not going to write the whole problem down. That takes a while. Okay. So here it goes. To use a certain computer database, the charge is $30 an hour during the day and $10.50 an hour at night. If a research company paid $411 for 28 hours of use, find the total number of hours charged at the daytime rate and at the nighttime rate. Okay, so I'm going to use D for day hours and N for night hours. But you could just as easily use X and Y. We need to make two equations. So last chapter, we did one variable, one equation. This chapter, we're doing two variables, two equations, okay? So one of the things it tells you is that there was a total of 28 hours that somebody used this database service. So we're going to say D plus N, so day hours plus night hours, total of 28. Okay? Then the other piece of information is that they tell you that the research company paid $411. So this is the numeric part. We're going to say $411, and the day hours was at one rate and the night hours was at one rate. The day hours was at 30, so we're going to say 30D. And the night hours was $10.50. So we're going to say plus $10.50 N. And so now at this point, you can choose any of the three methods. So logically, we'll think about it. Would it make sense to use graphing on this one? No, you could solve for one of the variables and get the slope and graph them each and see where they intersect. But that's probably not the best choice, okay? How about linear combinations? Linear combinations would work. We could multiply the first equation all by negative 30, right? And eliminate our D's. But how about substitution? Substitution, you need to solve one of the equations for one of its variables. And notice that the coefficients on the D and the N are both 1. So it's going to be pretty easy to get the D or the N by itself. So let's get D by itself. We're going to say that D is equal to negative N plus 28. And we're going to take that and we're going to plug it in or substitute it in to the other equation where the D is at. Okay. So we're going to have 30 times all this stuff that D is equal to, so negative N plus 28 plus 10.50 N equal to 411. Notice that I'm down to the N variable now, which is what you want. You only want, at this point, you should be down to one variable. If you're not, you did something wrong. Go back and fix it, okay? Now it's just like an Algebra 1 equation. You've got some distributing to do. You've got some combining like terms. You want to solve for the variable N. So I'm going to distribute here and here. That gives me negative 30N. And then 30 times 28, Punch it in your calculator. You should get something like 840. And then plus 1050n equals 411. Okay. So now we're going to combine our like terms. We've got negative 30n and plus 1050n. And I'm also going to subtract the 840 from both sides. And this is going to end up being negative, right? If you take negative 30 minus or plus 1050, you should get negative 1950n equal, and then with your calculator, you're going to go 411 minus 840. I got 479 negative. So if they're both negative, that's good because then it's going to turn out positive, right? Okay, divide both sides by $19.50. And it goes in there 22 times. That's the night hours. So what's the day hours? 6. 22 hours and 6 hours. Okay. Now, if you were asked to write it as a ordered pair, you'd go alphabetically. You'd say D is 6, N is 22. Okay? Any questions on example number 1? All right, let's try one more. So example number 2, it says, to measure the speed of the jet stream, a high-speed altitude west to east wind, a weather service plane flew 1,800 kilometers with the jet stream as the wind and with the wind and then back again. The eastbound flight took 2 hours and the westbound one took 3 hours and 20 minutes. Find the speed of the jet stream and the airspeed of the plane. Okay? So do you guys remember that distance equals what? Oh, no one knows this one? Right. Okay, so something times time. Rate. So distance equals rate times time. Okay, so we're going to get the the distance for each of the 2 planes, the one that's going east, the one that's going west, and we're going to set them equal to 1,800, which is the kilometers with the jet stream. So the east, the plane that's flying east is with the wind, and the wind we're going to call W, and the airspeed, well, I guess we should write that down here. So we'll call P, let me move this up a little. P is going to be the airspeed. The W is going to be with the wind. So the plane that's flying east is with the wind. So we're going to say that it's P plus W. That's going to make the plane fly a little faster. And the one that's flying west is minus the wind. It's flying a little slower. The time that it's going to take the east one is less. It's only 2 hours. And the west, the plane that's going west is 3 hours. What did it say? 3 hours and 20 minutes. So think, I'm going to write that over here for a second. 3 hours and 20 minutes. Now minutes there aren't 100 minutes in an hour, right? How many are there? 60. So if you have 20 out of 60, what is that as a fraction? 1/3. So this is 3 1/3 hours. So the distance for each of these is going to be the rate times the time. So I'm going to say 2 times P plus W. And for this second one, I'm going to say 3 1/3 times P minus W. All right, so the first equation is going to be 2 times P plus W equals the total distance of 1,800. And the second equation is going to be 3 1/3 times P minus W also equals 1,800. They both go the same distance. It's just going to take the westbound airplane longer because the wind is going against it. Okay? Happens a little bit too when you're driving. You may not realize it, but if the wind is blowing on you, your car, even if you're pushing hard and driving fast, it's slowing your car down and you actually burn more gas. Okay. Anyway, all right. So, we have a couple options. We can use graphing, we can use substitution, or we can use elimination. So graphing makes sense. Now, substitution, no, we could distribute and then try and get in, but that would be complicated. So let's try elimination. Okay? So, I can see that if I didn't have these coefficients out front, I actually already have opposites on my W's. Okay? So since this first equation is being multiplied by 2, what's the inverse operation of multiplying by 2? Dividing by 2. So I'm going to take this whole first equation and I'm going to divide everything in it by 2. Okay, even this 1,800 over here. So 2 divided by 2, that eliminates that, and I'm left with P plus W. And then 1,800 divided by 2 is 900. That looks a lot easier, right? Okay. I'm going to change this mixed number to an improper fraction. So I'm going to go 3 times 3 is 9, 9 plus 1 is 10, so this is actually 10/3. So that means I need to multiply this whole second equation by what? We want to multiply by the reciprocal. So flip that fraction over. We're going to multiply both sides by 3/10. Okay? Which on the left side over here cancels, and we're left with P minus W. And then this might be a little hard to do in your head, but if you do it on your calculator, it's pretty easy. You just multiply the 3 times the 1,800 and then divide by the 10. I got 540. Now they're set up perfectly for elimination, right? Okay, so the W's eliminate, which is the way we designed it to come out. The P's we add together, we get 2P. And then the 915 or 540 add together, I got 1,440. Divide both sides by 2. So P is 720. That's the airspeed. And I think it was like in kilometers per hour or something like that. So we'll just say kilometers per hour. Then we just need the wind speed. Okay. So we can plug it into either of these two. The first one looks a lot easier, right? So we're going to say 2 times, plug in the P of 720 plus W equals 1,800. I'm going to divide both sides by 2 first, because I just like to get rid of that fraction right away. So 720 plus W is 900. Subtract the 720. I got W is 180. So that's the kilometers per hour. And that's our wind. All right, finish copying that down. The good news is you only have, how many of these? 10, I think. Is it 10? Oh, 12. I lied. 12. Okay? And all the odds, you can check your answers in the book. If you need to check any of the evens, let me know. I'll open up my answer